initial temperature of that metal? 100 degrees centigrade, right? All right, so now that's fine. There we go. 100 degrees centigrade. Now, would you like to measure it for real? Just in case we're off a little bit atmospherically? Let's measure it for real, okay? So I'm going to stick the thermometer in here, and I don't want to let it touch the bottom of the container. And I'm just going to let it go. And we're going to see what we're going to get. Okay, the thermometer's going up, going up, going up. Because you do realize that the temperature that water boils at is 100 degrees centigrade at 1 atmosphere. So if there is a little bit of atmospheric variation based on whether that will change, 100.4, Brittany, is the actual honest-to-goodness temperature that water's boiling at this exact minute in Jacksonville, Florida. Okay? Now, that means that the pressure's off just a little bit. Okay. What is the mass of the water? Would I need to measure the mass of the water boiling? No. All this is for is so I know the initial temperature of that metal. You see, I can put a flame on that metal. But then how are you going to be able to test the temperature of that metal? You with me? I mean, certainly they make laser probes now. You just shine a laser on it and boom, you got it. But the problem is it going to be uniform temperature? No. All right. So the water is the best way to have that quenching there. Okay. Now, what's the mass of the water? Well, it's going to be in a calorimeter. Now, remember, a calorimeter is an extremely expensive and well-insulated piece of equipment, right? Or a styrofoam cup. The FSCJ's calorimeter, right? Now, is this a pretty good approximation? What do you think? I mean, you could pay $3,000 for a real calorimeter, or you could use this. Is this a good approximation? Well, I'll tell you what. Well, I ask this gentleman here to hold it. And I'm going to pour that scalding water in the cup. Is it going to hurt him? No. So it's pretty insulated, right? Now, will he be able to feel some heat? Yeah. But he's not going to be out of his seat, right? Unless, of course, I accidentally spill it on him. Okay, so here's what we're going to do. We are going to come over here and we're going to put this empty cup on that balance. And we are going to hit the tare button. And I'm going to come over here and I'm going to put a spritz of water in. Okay, just enough to cover the metal. So when I drop that piece of metal in here, I want just enough water to cover it. What if I filled the cup completely up? That means the temperature change would not be as noticeable. All right, back to the balance I go. So, Brittany, the mass of the water is 50.77 grams. So I have approximately 51 milliliters of water. Okay? Now, what's the initial temperature of the water? Well, it ain't the boiling water. It's this water. I don't know what that is. Do you know what that is? No idea what it is. Watch this thing turn over. How cute would that be? All right. So we're just going to let that sit there and get thermally equilibrated, right, for just a moment. You kind of just want to be sure that this is stabled out a bit, maybe circle it around. All right, it seems pretty constant, pretty stable at 22.1, Brittany. All right, 22.1 seems to be a pretty good estimate. Okay, so now what are we going to do? We are going to take this hot metal, put in that cup, and quickly measure the temperature. Are you with me? Okay, let's do that. Here we go. Okay, I'm capping it off, putting it in here, and starting to swirl. Now, I'm trying to be careful not to touch the little metal part of the thermometer, right? Because I don't want that thermocouple to read. So I'm at 23.1, 23.2. Wait just a second. So I'm, sorry, I guess that was rude to say, I guess I'm used to a 2-year-old. 23.3. So what's going on is this thing is gradually going up, and then what's going to happen? It'll level off and start coming back down to room temperature, right? I want the highest temperature that it read, okay? So if right now we are still stable Mabel at 23.3, And we'll see here whenever it starts to come back down. 23.2. So the highest temperature was 23.3, all right, that it reached. So I'm going to turn that off and let that be cooling down while we finish the problem. Oh, so that means that that's also the final temperature of the metal up there too, right, Brittany? Well, look at that. Everything is filled up but what? Cm. So we have ourselves a good situation now, right? Do you want to work the problem, or you want me to take it? You want me to take it? I take that. All right. So here's what we got. I thought I was going to get to sit down and relax a minute. All right. So we got the mass of the metal, specific heat of the metal, final temperature of the metal, initial temperature of the metal, mass of the water, specific heat of the water, final temperature of the water, initial temperature of the water. That is our master equation. Brittany's did a wonderful job. She got everything. It's even easier than before. She got everything, single thing there. Can we find out what this metal is? Well, the mass of the metal is 28.96. The specific heat of the metal, don't know. That's my only X. Okay. The final temperature of the metal is 23.3, and the initial temperature is 100.4, right? Because we know that the weather is off just a smidge from 1 atmosphere, and the water boiled at that. Plus, another thing too is water coming out of this faucet. Do you think it's got minerals in it in Florida or no minerals? Minerals, God knows, right? So that also bumps up the boiling point of water a smidge. Okay. That's called a boiling point elevation, which we'll get to later. Now, hopefully, sometimes we don't get there. Mass of the water is 50.77. Specific heat of water is 4.184. Final temperature of the water, 23.3, and the initial temperature is 22.1. Wow. Let's work on the right-hand side first, right? Because there ain't no X's over there. So, 23.3 minus 22.1 times 4.184 times 50.77. So the right-hand side now is 254.906. I'm going to wait on you, and somebody starts shaking their head when they're with me. These two ladies, Cassandra, Brittany, you shaking your head yet? She's shaking her head. Okay, I'm happy. All right. Now what am I going to do? Well, let's subtract these two numbers, right? So 23.3 minus 100.4 equals negative 77.1. Times a negative 1, so now we're at positive 77.1, times 28.96. So here's what we got. We got ourselves 2232.816x. You see, that was simple. No distributing, none of that. All right. Dividing by, of course, 2200, so it's 254.906 divided by the second of the answer. What are we going to get? 0.114 joules per gram degree centigrade. That is the specific heat of this metal. All right. That's what I measured. Did you guys get that answer? Okay. So let's come back here then. Get in your table on page 73, and is there a metal that is close to that? What's the metal that's the closest to it? Lead. So what does that say right here? What's that say?
PB.
PB. So I had lead, right? Now let's look at this here just a moment. So somebody said lead before I even showed her what it was. So isn't that pretty neat? You can find out what this metal is, and we can use a thermometer. We've only used the thermometer.